Very good morning, dear children. Let us start our today's class with a prayer. God grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. Amen. Dear children, for today's class, we are going to see the second part of your 11th lesson, section number 11.5, atomic number and mass number. Dear children, how many of you know about atoms with their symbols and electron and proton numbers? Most of us may not. It's not at all a problem. We are going to learn that in this lesson. But we should use those elements with their proton and electron number initially for example. Okay. For example, if we take hydrogen atom means. What is a hydrogen atom? I may write hydrogen atom like this. How? H1, 1. This 1 shows number of proton plus number of neutron. Okay. Here the hydrogen atom consists only of proton. So the number of proton in hydrogen atom is 1. Only 1 proton. What about helium? Helium I may write He4. This 4 will be 2 plus 2, 2 neutron, 2 proton. So, number of protons is 2. Similarly, in the case of gold, it has 79 protons. So, what is these things explains? This shows that the number of protons in the nucleus of an atom decides which element it is. It is not only number of proton, it is also number of electrons. So, it is very important number known as atomic number. Atomic number is nothing but number of proton that is equal to number of electron. In an atom, number of proton must be equal to number of electron. If we say it is an atom means number of proton must be equal to number of electron. Protons alone do not make up all of these mass of atom. Neutrons is also there. So, in the previous video we have seen that at center nucleus will be there. Electrons revolve around this nucleus in a particular orbit. So, inside this nucleus, protons and neutrons are there. So, the mass of the atom or mass of the nucleus is not only contributed by proton but also by neutron. So, we should also consider neutron. The neutron is in the nucleus also contribute to the total mass. The mass of the electron can be regarded as so small that it can be ignored. So, we need not to consider the mass of the electron. In the table 11.1, they have shown about the mass of the electron is 9.11 in 10 to the power minus 31 kg. So, it is very minimum. So, if we consider the whole mass of an atom means we can neglect the mass of the electron. We only consider mass of the proton and mass of the neutron as a whole as the mass of the atom. Okay, as a proton and neutron have the same mass, the mass of a particular atom depends on the total number of protons and total number of neutrons present in that. This number is called as mass number. So, there are two important numbers, one is atomic number, another one is mass number. What is mass number? Mass number is equal to number of protons plus number of neutrons. See, atomic number of protons must be equal to number of electrons. Here mass number of protons plus number of neutrons. So, for any element, the atomic numbers are shown as subscription and mass number are shown in the superscription. Let's see that. This is the symbol. So, X shows you the symbol of the element. For example, hydrogen means H. Helium means He. Okay. Mass number in the superscription. So, for helium 4. Atomic number in the subscription. For helium it is 2. Example, here they have given nitrogen. Now, for nitrogen 14 is mass number, 7 is atomic number. What is this 14? 14 implies number of protons plus number of neutrons. Number of protons plus number of neutrons. 7 implies number of electrons. Okay. So, let's see that. Here they have given you activity 1. You do it by yourself. If you don't know means you ask me anytime, I will explain you. The difference between the mass number of an electron or element, and its atomic number is giving the number of neutrons present. I would like to know the number of neutrons alone, means I have to subtract the mass number. I have to subtract the atomic number with mass number. So A minus Z will result in n number of neutrons. For example, take magnesium. In the case of magnesium, mass number is 24, atomic number is 12. What is the number of neutron? 24 minus 12, that is equal to 12. 12 is the neutron number of magnesium. Similarly, you will be able to calculate the neutron number in aluminium, phosphorus, oxygen and chromium as given in your textbook. Okay. Next we need to see about electronic configuration of an atom. So you also know electrons occupy different energy levels called orbit or shell. The distribution of electron in different shells is called as electron configuration. This distribution of electron is governed by certain rules or conditions, that is known as Bohr or Bury rules of electronic configuration. So let's see the shell name. KLMN, these are all the shell name. KLMN or the shell name, and value of each shell, value of n in each shell is 1, 2, 3, 4. Okay. So what is the each cell, what is the number of electron equal that can occupy each cell? It can be calculated using this formula 2n square, where n is the serial number. N is the serial number of the shell. Let us calculate for K. K means 2n square is the generalized equation, isn't it? Instead of n, I have to put 1. Okay, 2 into 1 square. So 1 square is equal to 1. 1 into 2 is equal to 2. Only 2 electrons can be occupied in this K shell. More than 2 electrons cannot be occupied in K shell. The third electron should move on to the L shell. Is it clear? Please follow me. If I would like to calculate for L shell, the generalized equation for finding out the number of electrons that can be occupied in L shell is 2n square. So 2 into, for L the value of n is 2, for L shell the value of n is 2. So 2 into 2 square, 2 square is nothing but 4. So 2 into 4 is equal to 8. So 8 electrons can be occupied in L shell. More than 8 electrons mean it should move on to M shell. So 2 electrons only be placed in K shell. In 8 electrons only be placed occupying in L shell. Similarly for M shell it is 18. Number of electrons for N shell it is 32. Okay. That is rule 1. Rule 2. Shells are filled in a stepwise manner. It should be filled in a stepwise manner. Rule 3. The outermost shell of an electron cannot have more than 8 shells. If it is in the outermost shell means it only possesses 8 shell alone. Okay. It should not possess 18, 32 electron shell. So the outermost shell for any orbit should be L orbit. Okay. For example, electronic arrangement in calcium having 20 electrons means we should arrange the electron. First we should put 2 electrons in K shell. For this calcium, 2 electrons in K shell, remaining 18 electrons. So 8 electrons should be placed in L shell, remaining 10 electrons. See in this table, M shell can occupy or can have 18 electrons. But see, I am drawing calcium. This is calcium nucleus. The first orbit it can be 2 electrons. In the second orbit 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. In the third orbit I can place, this is the mth cell, I can place 18 up to 18 electrons in this mth shell. But if I place the remaining 10 electrons in this M shell means it can occupy, but it violates the step 3. because the step 3 says that outermost orbit should consist of 8 electrons only. So in the mth shell I am placing only 8 electrons. Only 8 electrons. 1, 2, 3, 4, 5, 6, 7. Sorry, 7, 8. 8 electrons. Remaining 2 electrons I shifted to the nth orbit. Remaining 2 electrons. Is it clear? Even though M shell can occupy 18 electrons, I am not placing 10 electrons in the mth shell since it violates the rule 3. So the outermost orbit should consist 8 or less than 8. So M is equal to 8, N is equal to 2 in the case of calcium. Is it clear? Yes. Next I am going to geometrical representation of atomic structure that I have explained to you using this calcium itself. But let's see the example which is given in the textbook itself. For here they have given oxygen as an example. Its atomic number is 8 and its mass number is 16. Neutron number is 8. We can calculate as A minus Z. 16 minus 8 is equal to 8. So number of proton 8, number of electron 8. So what will be the electronic configuration? In the K shell there will be 2 electrons. In the L shell there will be 6 electrons. So I should draw like this. Is it clear? Okay. Next we need to see about valence electron. What is valence? Because in the world we are seeing many molecules and compounds. We are not using elements. For example, I am using chalk. It is a compound of calcium. It is not simply calcium. It is a compound of calcium. In many cases, I am not simply using an element itself. Everywhere I need to go for compound. For that, it need to be bind to each other. For that binding, I should know about valency electron. So let's know about valency electron. Above example, we can see that there are 6 electrons in the outer shell of the oxygen atom. These 6 electrons are called as valence electron. The outermost shell of an atom is called valence shell and the electron present in that cell is called as valence electron. The chemical property of the element are decided by these valence electrons since they are the one that takes part in the chemical reaction. So any chemical reaction, that reaction is determined only by the valence electron. Okay. So the element with same number of electron in the valence shell shows similar properties and those with different number of valence electron shows different chemical properties. So elements which have 1 or 2 or 3 valence electron except hydrogen or metals. Hydrogen is not a metal. So if the outermost orbit has 1 electron, 2 electron, 3 electron means that is valence electron, they comes under the category metals. If the elements with 4 to 7 electrons in the outermost shell, then they will be classified as non-metals. Let's know about valency. Valency of an element is the combining capacity of the element with other element and is equal to the number of electrons that take part in a chemical reaction. Valency of the element having a valence electron 1, 2, 3 is respectively 1, 2, 3. If the valency of the element having valency electron like 5, 6, 7 means their valency is 3, 2, 1 respectively. That is, if 5 electrons in the outermost orbit name is valency shell and the outermost electron's name is valency electron, but its valency is 3. I should subtract from 8. 8 lende 5 subtract panna 3. 3 is the valency number of that element. Is it clear? Even though outermost shell occupies 5 electrons, valency electron number is 5, but its valency is 3. Valency electron number is 6 means its valency is 2. Valency electron number is 7 means its valency is 1. I should subtract from 8. Is it clear? So, if the outermost shell occupies completely 8 electrons means 0 valency, inert gases will come under this category, 0 valency. Is it clear? Okay. So, here they have shown table 11.2 shows you the arrangement of electron in an atom of element from 1 to 20 This table will help you to draw this figure 11.8. Okay, this 11.8 shows you detailing. I would like to explain here now and there. See, for example, I would like to draw carbon. Why I took carbon as carbon as an example means it will be very helpful for you if you move on to 10th standard. New lesson, full lesson is oriented with carbon. So carbon 612. Carbon 612. So what is this 6? It implies it is atomic number, 12 implies mass number. So I have to subtract A minus Z to know N. So 12 minus 6 is equal to 6, that is neutron number is 6. Okay. Now I need to draw electronic configuration of this atom carbon. So at center 6p 6n. I have found 6 neutron number, no? So this is nucleus 6p 6n. So the remaining 6 electron is there. How should I place? In the K shell 2 electron. So 6 minus 2 remaining 4. This remaining 4 is placed in this L shell. 1, 2, 3, 4. Like this I should draw atomic structure. So the electronic configuration is the first shell 2, in the second shell 4. So 4 is the valency of carbon. 4 is the valency of carbon. Okay. Now I would like to draw for a inert gas neon. Neon is an inert gas. For this I would like to draw this electronic configuration once again. Okay. See this. Neon is the symbol of the element. 10 atomic number, 20 mass number. 20 minus 10 is equal to 10, that is nothing but neutron number. So 10 proton, 10 neutron in this nucleus of neon. So how many electrons? 10 electrons. The K shell 2 electrons. Remaining 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the outermost shell is completely filled. Completely filled. Electronic configuration 2, 8. Completely filled. So, rule 3 said that outermost orbit can occupy 8 electrons only. So, for neon it is completely filled. Valency is 0. 8 minus 8, valency is 0. So, it is called as inert gas. It will not react with anything. So that it is called as inert gas. Is it clear? So, from hydrogen to calcium they have given in your book. You go through and try to draw that detailing. Now I would like to move on to the next section. 11.6 Isotopes, Isobars and Isotones. What are isotopes? In nature, a number of atoms of elements have been identified which has the same atomic number but different mass number. See this example. For example, protium, deuterium, deuterium. I can write protium as H11, H12, H13. Protium, deuterium, deuterium. Okay. This subscription 111, number of electron is 1. The superscription 123, mass number 123. So the same element hydrogen with same electron number, same atomic number, different mass number are known as isotopes. I repeat, what are isotopes? Elements of same atomic number with different mass number are known as isotopes. There are some more isotopes are in nature. Carbon isotope, carbon 612, carbon 613, chlorine 1735, chlorine 1737. These are a few more examples. On the basis of this example, isotopes are defined as the different atoms of the same element have the same atomic number but different mass number. There are two types of isotopes. One is stable isotope, another one is unstable isotope. The isotope which are unstable as a result of the extra neutron in their nuclei are radioactive and are called radioactive isotopes. radioisotopes. For example, uranium-235, which is a source of nuclear reactor, and cobalt-60, which is used in radiotherapy treatment, or radioisotopes. These isotopes are formed due to the excess number of neutron. Next, isobars. Next, we need to know about isobars. See, they have given example argon and calcium. So, the elements name are different. This is calcium, this is argon. Their atomic numbers are different, 18, 20. Same atomic number will provide only the same element. It may not argon or calcium. So, atomic number are different, 18, 20. Their mass number are same. Bar irukalla, adanaladha the isobar. Mass number are same, 40, 40. So, how it is possible? They have different number of protons and electrons, but the mass number of both of these elements are 40. It follows that the total number of nucleons in both the atoms are same. They are called isobars. So, atoms of different element with different atomic number and same mass number are known as isobars. This is the definition. So, what is the definition? Atoms of different elements with different atomic number and same mass number are known as isobars. Next, we need to see about isotones. See this example, boron 511 and carbon 612. See, elements are different. Here boron, here carbon. Atomic numbers different, 5, 6. Mass number different, 11, 12. Then what is the similarity between them? Find out the neutron number. 11 minus 5 for boron, it is equal to 6. Find out the neutron number for carbon. 12 minus 6 is equal to 6. The neutron numbers are different. Okay, elements are different, mass number are different, atomic numbers are different, but they have same number of neutrons. They are known as isotones. Okay, so atoms of different elements with different atomic number and different mass number, but with same number of neutrons are called as isotones. I repeat, atoms of different element with different atomic number and different mass number, but with same number of neutrons are called isotones. Next, we need to see about laws of chemical combination. This thing and all explained in your book detailing. I just mentioned the 5 laws. Laws of conservation of mass, laws of constant proportion, law of multiple proportion, law of reciprocal proportions, Gay-Lussac's law of gaseous volumes. These are all the 5 important laws that has been explained in your textbook detailing. Up to this, I am going to wind up the lesson. I hope you all understand. All the best. God bless you.